Hello everyone, welcome to the third week of our course in cartography. Today we are going to work with some new stuff. We will work with big data, which might be new for many of you. You have probably studied about it, learned about it from different courses, but we haven't really done a lot of work visualizing big data. And given the characteristics of the data, there are some considerations to be taken into account. So hopefully it will be an interesting and useful tutorial for many of you. We will also look briefly at the topic of visualizing geospatial data in a non-cartographic way and see a few examples of how we can achieve that. I have already pulled the latest changes from the repository, so if you haven't done so, now is a good time to do it. Then we will have the week 3 contents. Let's start with the file called non-carto visualization with Python. Let's just open this notebook and go through the materials quickly. So the point here is that when we have discussed this in the course at some point, that this is a course in cartography. We are working with geospatial data. Most of us are geographers or geoinformatics experts, and the main way we communicate our data with other people or for ourselves is through making maps. But through this tutorial, we want to bring it to your attention that although maps are usually the most powerful way of visualizing geospatial data, they're not the only way. So depending on what you want to visualize and what are the things you want to highlight from your data, you may sometimes need to use other ways of visualizing the data without making a map. So remember that being a geographer doesn't mean that you always have to produce a map when it comes to visualization. So consider also the possibility that certain information in your data can be maybe better communicated sometimes through other methods. And this is where we want to, we will have a few examples of this. So this is one of the things. And the other thing is that sometimes with a combination of non-cartographic visualization methods, for example, a chart, with a cartographic presentation, a map, can become very powerful. So if the two are presented together and synchronized in a nice, efficient way, it can also be another way how you can communicate your results or your data with people. So why would you consider non-cartographic representation sometimes? Sometimes your data is just too complex and you want to just simplify certain connections in your data, emphasize certain connections. So it can sometimes help simplify the complexity, emphasize some certain connections. Also, depending on how much data you have or what kind of map you're creating, it can be so that comparison might be easier for certain columns in your data if you just make a chart, for instance, compared to showing it on a map. So this is something you may want to take into consideration sometimes. So maps are not always the only way to go. So here we will see a few examples, and we're going to discuss other ways how geospatial data can be sometimes visualized non-cartographically, but one of the examples that can be easily achieved through Python is using graphs for visualizing relationships from a geographical point of view. This can be basically the adjacency relationships sometimes. So if you want to show, for example, we have an example here from some of the states in the United States and how they are related or which ones are neighbor to each other. So this kind of relationship, of course, you can easily see it from the map, but if you want to just highlight very quickly what is the adjacency relationship between different states, another way to go could be creating a graph. So this is an option. So this is a very simplified subset of states. It doesn't include everything. It may not be comprehensive and it's just manually entered. Probably if you're working with a real life example, you have your data coming in other format, but here we just have a simple, we have a dictionary, Python dictionary, in which we have the key, which is the state and all the states that are adjacent to, for example, California in this case. And you can create a graph with a combination of Network X. It's the library that you have used. For those of you who have taken the AutoGIS courses, you probably remember this. It's a graph analysis library, which we have used for network analysis in AutoGIS courses. It's a graph analysis and visualization toolbox, like library. So it doesn't have to be a network. Of course, it can be any kind of graph. In this case, we just want to create a graph showing the relationships based on what we have in our US states neighbors dictionary data. So we are going to create a graph from our data. Then we are going to iterate through our dictionary and load the states and their neighbors and add it as an edge to our graph data. Then the rest is simple, just visualizing. We have a graph, then you just simply visualizing. And of course, we are familiar with Matplotlib, and we can visualize. This works with Matplotlib, so we can customize how things look. For instance, we know that we can adjust the transparency of our layer using adjusting the alpha value, or you can apply an edge color and directly specify what color you want, or you can just provide the hex code that we learned about last week. But this way you can customize your graph and visualize it. Let's just run this cell and see what we get as the output. So this is not the most beautiful output, but you can adjust and work with the graph. There are also options how you can customize how the layout is made, but I'm just going with the default now, and to show you that this is also a way of showing like proximity relationships, adjacency relationships in your geospatial data, if you think it's possible. Here, by taking a quick look at the data, which is an example data and not comprehensive, you can see that, for example, Nevada is very centrally located, being neighbors to at least 4 other states. Again, according to the data, we have to check if it is comprehensive enough. But you can get a quick idea how it works. So this is one example of how you can show this kind of relationship without using a map, and it can be useful sometimes for your work. Another example of visualization that is not cartographic but can be helpful for geospatial data is a chord diagram. Chord diagrams offer a powerful way to visualize complex relationship between different entities, and these relationships can be geographical, of course. By arranging entities along a circle with connections, or chords as they are called, between them, we can quickly grasp the volume and direction of interactions. Probably have seen examples of these. There are different software that can help you do this, but in Python there's a handy library called MPL chord diagram that is specifically designed to make this kind of diagrams for you. So let's just run the first cell. We have the library already installed in this environment. If it wasn't, we could have just run this cell to use pip channel to install the library, but it loaded without we could import it without problem. It used to be a problem at some point. That's why we have this line of code here, but I didn't need to run it. So next thing I'm going to do, well, I forgot to mention that the data we are going to use here comes from Flickr. So it's nature visits by continents. So we want to see the nature visit flow from different continents. So from where to where do people travel to visit natural areas? So there's a large data coming, a big data coming from Flickr, and it's stored as a CSV file in our data folder. So I'm going to just use pandas to load the data. Let's do that. And then let's take a quick look at our data set. So the data looks like this. So we have the origin and destination essentially, and how many trips have happened between these continents. And this is what we are going to use for visualization. And next thing I'm going to do is to use Matplotlib to create my plot axis, and then creating the chord diagram is quite simple. Let's just run the cell and see what we get as the output. So this is what I mean by chord diagram. Now that I it's easier to show it than explain it. So you can see that it looks like this. So you get an understanding of the flow between continents when it comes to natural visits. So for example, you can see a lot of trips are within Asia or within Europe, but there are also people coming from, there are travels between Europe and North America. So this is just an example. Of course, there are ways of showing this cartographically, and we are going to go through that in the QGIS version. But this is also, if you don't want to use map for whatever reason, there is a way to do that. And there's a library, and you can check out the recommendations, how it works, but it can facilitate the process of creating this kind of chart for you. So the combination of Matplotlib and this library allows you to specify the columns that you want to use for visualization, and then just add it there. And of course, there are parameters you can adjust to enhance how it looks. So like you can add padding, size of things, color of things, and yeah. But this is a good library if you need this kind of chart. You know that in Python there's a library for that. Another thing that we are not going to do, but just take a look at, is this example. This is coming from a paper that was actually published by some of our colleagues here. So it's a paper in which we have Tuuli Toivonen and Enrico. So yeah, so it's a good example showing you that the combination of maps and in this case charts that are synchronized with this in terms of where they're located, that this is so the chart is synchronized in terms of location, the latitude with this map. Sometimes it can be some color coding, but the combination of these two is very powerful. So you could have made this overcrowded if you had added these charts directly to the map, but just putting it next to the map has been a very good example of how we can combine cartographic and non-cartographic visualization to achieve a better communication of information from your data. So this was just a quick example. We are going to discuss this more in the class and in the exercise. But now let's move on to the main part of our tutorial this week, and that is working with big data. So I'm going to just empty the cell and run it again. We go through it together. I emptied the cells, restarted the kernel, and cleared the outputs. So what we are going to work with is making maps with big data, and we are going to work with a few data sets here. So one of the first data sets that we are going to work with is Flickr data from Finland. So we are not really thematically exploring data, but just visualizing and show you a couple of tips and tricks how you can efficiently and represent big data. So as you know, by definition, a big data refers to data set that is very large in volume, and there are different ways to put that threshold after which point is the data considered big, and this is a discussion we have made in other courses. But in essence, the data set we refer to as big data is a data set that is very large, and that can pose challenges to our visualization. One of the challenges is just purely technical. If the data set is large, comprising, I don't know, millions or hundreds of thousands of lines, it can be tricky. That's why if you haven't been motivated enough to use programming for visualizing data, this is a point where many people get enough motivation to learn, for example, Python to work with data. If big data is something that you come across quite often in your work, then working with it programmatically is usually more efficient. You might have had the experience that you're opening a very large data set in QGIS or other software, and it might just crash, or it might be it might perform very poorly. So we will see how to work with this in also, for example, QGIS, and you can use it for exercise, but Python shows a very effective way of handling such large data. So in the first case, we are going to use the Flickr data from Finland that is collected between years 2019 and 2023, and has been anonymized. So so the data is, so we can reuse it, for example, in this exercise. So let's just import our libraries, load the data, and take a quick look at what we have. As you can see, the data is large in size, so it takes a moment to load. But yeah, here's the head of our data, as you can see printed out here. So we have point data, where we have the months here where the data was collected, and we have, of course, the geometry, which is point, and pseudo ID, which we are not gonna use. But anyway, the data is big. We have 161,000, more than 160,000 points in our data, so it's quite large, and it covers all of Finland. So the data is big, and the points are representing the locations where the photo was taken. So we are not going to look at the photos, of course, or analyze the contents, but just purely look at the points and its distribution. In our data, we have a column named month year, which you can probably guess from the name. It contains the month and year when the data was taken. Let's explore the data. Let's explore the temporal distribution of our data quickly using time series plot. So this is another example of a non-cartographic visualization of geospatial data. Of course, we are exploring the temporal dimension of it, but it's just easier to do it, more efficient to do it using a time series in this case compared to any map. So this is an overview of the number of photos per month. You can see, for example, we have a clear peak in July of 2020, and also another peak around during winter of the year 2023. So this gives you an idea what is the distribution of the temporal distribution of our data, and this is something I guess we have seen in GeoPython courses, making this kinds of charts. But now one of the tricks we are going to learn now is to create a hex bin map. This is a popular kind of map that we have seen a lot in recent years, especially with the emergence of big data, big geospatial data. So hex bins are nice for and popular for a number of reasons. We're going to see how it looks like. So it's a map made of hexagons. So traditionally we have used like buffers, for instance, or we have used grid cells that are square in shape for visualizing things, for example, this density of the point distribution. But hex bins are useful if you're working with big data. So this is not the only way to go, and we will see other examples during this tutorial, but hex bins can be effective. So they are good for a number of reasons. They are efficient in coverage. Hexagons sit nicely next to each other, so you will get a nice coverage without any waste. So if you have circles, overlaps can become tricky. But with hexagons, you get good coverage. For example, if you're working within certain boundaries compared to a grid cell that is a square in shape, these hexagons can feel they land nicely. So if you're working within Finland, then on the border areas, this would work more nicely. So this is one of the reasons they're popular. Uniformity of data representation. So the hexagons are uniform in shape. Each hexagon has 6 sides of equal length, which results in a more uniform distance between the center of hexagon. So if distance analysis is something that is relevant to your work, different kinds of proximity analysis, then hexagons work nicely from a calculation point of view. So as I said, like nearest neighbor proximity analysis, they work more nicely with hexagons. Visual appeal compared to square-shaped grids, these usually look nicer. They look a bit fancier. So we are aiming to make nicer looking maps as part of our job as a cartographer. So this is something that also we should take into account. And efficient, they're computationally efficient. So despite a seemingly complex shape, algorithms that are used for processing hexagonal grids are actually more straightforward and computationally efficient for spatial data analysis. So this is another reason why we might consider using hex bins in our visualization if we are working with very large data, like big data in our case. So these are some of the reasons why you may need this kind of map. So luckily for us in Python, there's a library that can help us create this hex bin fairly easily. So I'm going to import the library. Unfortunately, for some reason, this is missing from our environment. So I'm going to install it. So you might have needed it already, but you can, using exclamation, you can just run a line of Python, like you can run console commands. So here I'm going to just use pip channel to install h3 library. Unfortunately, every time you start a new session in your Noppe environment, this is wiped out. So you have to repeat this process. And I'm sorry for that, but it's not very difficult. We can just run this and get the library installed. And it's also imported. And we can print, here we are printing the version of the library. So now that we have the library installed and imported, we can move on to the next cell. This is again importing the library, which we do not need. We have already imported it up here, but we are also importing Shapely. We are going to work with geometries and Matplotlib, Shapely polygons, and we are going to later on zoom our map on Helsinki area. For that reason, I have put the coordinates of Helsinki just somewhere in the middle of Helsinki area. So here I'm writing a function to assign hexagons. One thing is that this library has recently changed. So if you're working with newer versions of this library, here, the environment here is a bit older to make it work for all the libraries that we need. But if you're working with newer versions of Python, some things have changed. So for example, the longitude, latitude order has changed to match with the GeoJSON format. So if you do this in your own local environment with a different version of this H3 library, you might see that things are different. So you have to flip the order of longitude and latitude. Otherwise, the map will just look the wrong way. So a few things have changed, and some name of some functions, I guess this one has changed. So yeah, so if you work with new versions, you will get some error, but it's easy to see that. Just check the documentation, see the changes. But yeah, I'm going to assign each of my points to hexagon using a function that is built in this H3 library. So I just read the coordinates and it assigns it to a hexagon. And yeah, so I'm going to go through my data and apply this function that I've created. So each point will be given to a hexagon, and then I aggregate my data within each hexagon and get the count. So what I want to visualize is the number of points that fall into each of these hexagons. So that's what I'm trying to achieve with these couple of lines of code. And then once I have the hexagons, I have to create the geometries from them so that I can visualize them. And for that reason, I'm using the Shapely polygon that I've already imported to create my the boundaries of the cells so that I can use them for visualization. Then I'm converting it to GeoData frames, so I will be working with the familiar GeoPandas for visualization and handling the data, and just using Matplotlib to visualize it. And to make things look nicer, I'm also applying a classification of my data using natural breaks and breaking it into 5 classes and applying a color map, automatic color map. So let's run this cell, and since the data is a bit large and there's a lot of calculation happening here, it might take a couple of moments, but yeah, but that was fairly fast. So the library is quite efficient. This is the grid. So at this zoom level, we cannot see, but what we have here is this hex bin map. We have a classification of our data, and you can see the classes here, showing the number of points that fall within each hexagon. To make things a bit, take a quicker look, take a closer look to our data, I'm going to recreate this map, this time centering it on Helsinki. So I'm going to apply this set x limit and y limit using coordinate from Helsinki. So I rerun this now. I should have a zoomed in map of Helsinki area. So you can see this is how it looks in Helsinki. We have these hexagons created, and for each of them we calculated the counts of points, and we have visualized it with different colors. So there's a breakdown of what we have done in each of these lines of code that you can check out. And of course, they come from the documentation of the library we have used. You can also check out the library. Later on, we are going to work with, now we are going to explore our data a bit better. So this is a static map. We cannot explore the data so easily. So now quickly we create a choropleth map using a Plotly library to explore our data interactively. I'm not going to go through this because we are going to revisit this library and the topic of creating interactive maps in week 4. So I will just quickly make this using Plotly Express to show you how our visualization looks like. And this is what we have. So you can, like I said, we are going to do this again next week. But you can just quickly browse your Higgsbin map and see what you have. So this works very nicely, very efficiently if you are working with very large data set. Okay, so this was one example of big data. Now we are going to move on to the next part of this tutorial, continuing with big data sets, but this time a different data. So we are working with student mobility to Germany. So this is a large data. It has been, I guess, published like as part of MobiTween project conducted at Digital Geography Lab. So if you want to get access to the large data set, it's like all exchanges within European Union as part of the Erasmus program from certain period. So it's a very large data set. But to make it more efficient for our case, I have limited the data. We are limiting the data to mobility to Germany to just make it simpler. So the full data has been processed by Tuomas from and Ola in working in MobiTween projects. So you can contact them or just check DGL pages to learn more about data. But here we are just using the data, a data set that I made small. So it's just 2018 and it is mobilities to Germany. So I'm going to just use this smaller data set. The full data is very large. So it would take longer here to process, but you can work with it if you want. So I'm going to read the data, the smaller version of the data, and I'm going to, so we are going to use in the country, we have the short names for countries, so we are going to use these to do the visualization. So we have this two-letter. We are going to look at the data a bit later. We are filtering mobilities that end in Germany. So that's why I'm checking Germany. The short name for Germany, which we have already converted to string here, is DE. Yeah, so we created a new columns here, origin country, destination country. We just read what we had in the origin destination column originally and just made sure that it's a string. And then we are going to use this like to just filter our data to make sure that we have only things from data from Germany, like where the destination country is Germany. And then we are aggregating our data by origin and destination country to count the number of mobilities, similar to what we did earlier with Higgsbins, but here we are trying to get the count for the mobilities. So using group by is something we learned about already in GeoPython course for those of you who have taken this course. And I'm doing this group by using these two columns and trying to get the size to, so I'm getting the number of counts. So I'm also writing it as counts in my data. Then I'm merging this back to have a single geometry that I'm going to use for visualization and dropping the duplicates in our data, just cleaning up data. This is not part of our visualization, but of course we need to do this for making a good map. And then another thing I'm using, of course, you can just use Contextly or some other library to add a base map, but it just looks nicer, as you will see, if we have the borders of Europe added just through a vector data. So I'm not going to use a base map like a ready base map, but instead I have gotten the shapefile of European countries' boundaries from somewhere, and I'm going to use that as my base map. So I'm loading the data here and then getting it to the right coordinate system so that I can use them for visualization. So let's just run this cell and get our data loaded and prepared for the more fun part, which is the visualization. So what I'm going to do, later on I will show you, well, what we are going to do, well, you will see if you just visualize the raw data, you will see that there are a lot of lines. So it just becomes just so messy that you cannot see anything from the map. That's why there's a technique called edge bundling. So what you do, you essentially bundle the lines together. So you have a lot of lines coming from Helsinki to Germany, for instance, from Finland to Germany. Instead of having all hundreds of them visualized separately as separate lines, that would just make your map unreadable. You can just bundle them into a line. And if you want, you can adjust the width or the color of that line to represent the volume of mobilities between Finland and Germany. So there are ways of doing that. It's a bit like it's a bit tricky thing to do. Not tricky, but it takes a bit of work. But luckily, in the DGL recently, as part of the same project which I mentioned, they have developed a Python tool for performing edge bundling for regional mobility data. So they have particularly worked with this data. So if you're curious, I encourage you to check out this tool. It's a very good tool. It makes a very nice visualization of the data. I guess there's an example of this somewhere, but yeah, you can download the example data and the tool from here. But on the DGL website, you can also see examples of how the visualization looks like. But this is a bit like, if you just use that tool, you can get a very good visualization. But now we are not using the tool for this work, for this tutorial. Instead, we are doing some manual work, so not depending on the library. So to make my visualization nicer, now the points go to different places in Germany. So I'm not interested in all that detail. I want to just get the lines to a certain place in the country, in all these countries. So what I'm doing, I'm just getting the centroid of that country for my visualization. And I'm doing this manually. So I'm just getting the centroid of the geometry. And then calculating the centroid. And then, yeah, so I will see which country does the point fall into, and then using the centroid of the shape of the country to form our visualization. And then I'm relocating each end of the line to that centroid. So I don't want the line to just end up somewhere, anywhere in Germany, but to the centroid that I have calculated. That's why I'm doing this relocation. And then just applying this, the functions that I've defined here to my data. So just run this. It complains that the centroid we have calculated may not be super accurate due to projection related matters, but it doesn't affect us here because the exact location of centroid is not essential to our work. We just want to visualize some central point in our data. But if you're doing some calculation in which the centroid's exact location is important, then you should pay attention to this warning that you are receiving. But in this case, I'm just getting the centroids calculated. So now we get to the fun part, which is to create the visualization. And for that, I'm just going to use matplotlib, the good old library that we are very familiar with. And then I'm getting my data to a coordinate system that works well in Europe. So I'm getting both the boundaries and the aggregated data to this coordinate system. Next thing I'm going to do, I'm normalizing the count for color mapping. So I'm going to assign a color to the lines depending on how thick the line should be, like, or what is the volume that is represented by the line. And for that purpose, I'm going to normalize it so it's mapped more nicely using the CMap. So in matplotlib, I'm importing color maps.getCmap that automatically assigns colors to my values, and it works most nicely if you have normalized the values. So that's what I'm doing up here, and then clearing the CMap. So you can also use some automatic CMap like we have done very often, but this works more nicely for our data. We are customizing it. Then I'm going to add the boundary to the map using gray and applying some transparency and adjusting so the line width. So I'm paying attention to visual hierarchy. I don't want to overemphasize the borders of the European countries in my map, as this is not the main point. I'm just, it's a base map showing us where we are located without data, but I don't want to overemphasize it. Then I'm going to plot mapping mobility lines with color mapping that we just created up here. Yeah, I'm just making sure that everything is done properly. Okay, let's just run this and see what we get as the output. So we are working with a large data set. That's why it takes a bit of time to get the output. Yeah, so I'm applying a color based on the customized mapping that I have used. I've created here based on the counts. I've also using the line width, using the normalized counts again, and multiplying by 5 to get the right size. So this is by trial and error, so you can just go with other values and see how thick you want the lines to become. So yeah, so this is the output. I have a background, which is the borders of the European countries, and I have a line representing the mobilities to Germany, and the thicker the line or the more yellow the line, then the bigger the volume is. So there's a lot of mobility coming from Turkey, for instance, to Germany, or there's there's a lot from Spain to Germany or from the UK. So this is a map, and I've chosen these colors to work with. You can use different shades of color. I've gone with copper, that works nicely in these cases, but you can try with different color maps, and create different visualization. Of course, the color is not even so essential here. It makes the map look a bit nicer, but the width of the line is already showing the volume. So yeah, so I'm also simplifying them. As you can see, I've created a simple legend just showing the volume is low, medium, high. But of course, if the exact numbers is important to the reader of the map, then you can go with a better, more detailed legend showing you a bit more information about the volume. So here you get no idea how many travels are happening, but this is just for simplicity and depends on what you want to achieve with your map. I already mentioned the edge bundling tool that is developed in Digital Geography Lab. You can check the tool, and if you want, you can use it in your exercise. Now we are going to work with a third data set in our tutorial, and that is the speed test data. Many of you are probably familiar with this website, the speed test by Okla. That, it's an app. It's a there are phone apps, and also there's a website where you can check the speed of your internet. Many of you have probably used it. One good thing is that they publish a lot of the data sets openly, so you can just download, and it's very large data. So if you want to work with big data, big geospatial data, you get a lot of good data showing different characteristics, different qualities of network around Finland, around the world. So we are going to work with this data set and work with a library called ion boards. This is a very specific library that works nicely for this kind of map, but there are a lot of libraries that you can use for visualizing your data. So this is just to showcase one library and how you can use it to create a nice map of your very large data set, interactive map. So I'm going to use this library. There's documentation of the library that you can check. There's the link. I'm going to import many of these libraries we have imported before, but I'm going to do this again now to make sure everything is there. I'm also, of course, importing the Lombard library and some sub-modules from the same library. So let's just import this and hope that the library is already installed. It is, so we didn't get any error, which is nice. Next, I'm going to fetch the data. So we haven't downloaded the data, so it is online. I'm getting it from Open Data, and it's coming in Parquet format. This is a format that works nicely with very large data sets. So if you're getting if you're working with big data a lot, you probably have come across this file format. It works nicely also with geospatial data. Then I'm going to save the data. So I'm saving it to my data folder, and yeah, so here, because I've run this a few times before, we are checking if it exists, and if not, then it will be downloaded, saved, or just we read the existing data if it already exists, and then just loading the data and reading the columns. So let's just run this and get also take a look at the head of our data to see what we have and the length of our data. Yeah, so to view this, I should have put it in print because it's overwritten by this other print up here. So, okay, so this is what our data looks like. We have the average data speed by kilobits per second. So that's the main information we are using for our visualization. And then we have the geometry, so we have points. And then the data is very large. As you can see, we have almost 4 million points in our data covering the whole world. So it's a very large data set to work with. Then we are going to use this library, the Lombard library, to create a map. So what we should do with this library, like I said, it's a very specific library, and you can check the documentations. But what you have to do with this library is to first create an instance of your map, and then you continue editing the map, and then the instance gets updated. So I'm going to run this to create my instance of map, which I'm calling M for simplicity. So now the map is created. So it's just a simple map that, it does a lot of like pre-processing on your data. So you get the data is very large, but the visualization is working nicely, and it's very interactive. So you can browse your data, get an idea of the density and like distribution of the data around the world. And also in this case, we are also seeing a pop-up, a tooltip actually that shows you the speed of internet in different locations where the data has been collected from. So this is the map created. Now I'm going to further customize my map. I add a fill color to my map, so you can see that I updated the color. So the instance is the same. I'm not creating a new map. It just gets updated as I assign different colors. In this case, I applied a bluish color. And this works nicely in Jupyter Lab, and you see that they have included this on Course's website as well, and it loads nicely. So if you are creating an interactive map using a very large data set for web purposes, then this works nicely. You can also export it as HTML. Yeah, so now I'm going to improve my visualization, like using the internet speeds. I'm going to normalize the values, and I've also provided a minimum a maximum bound for internet values, which I'm going to use for normalizing my values, and then assigning a color based on the internet speed. And then I'm going to update the fill color, the color of my features and the map, using this new color map that I have created using the normalized values. So let's run this and see how it changes the looks of my map. So now I have different colors on my map. Yeah, so this is interactive. You can browse and see, get a quick look of how the data. So in Europe, for instance, the data is rather consistent. You don't see a lot of color variations. But then if you look at other parts of the world, the global south and different regions, you can see there is more diversity when it comes to the speed of internet. And of course, you can adjust how you're treating your data to get more details out, this depending on what you're doing. Let's run the next cell. So what we are doing here is to adjust the radius of the circles based on the normalized data that we calculated here, and updating our map again. So there are a number of things you can do with your map using this library that you should, and if you're interested in using this library for your work, you should check out the documentation. But as I said, this is not the only way of doing this. And there are many libraries out there that can help you handle your data efficiently. But this is a very large data set. One of the best things about this library, why I have included it here, is the efficiency. So you saw that we had millions of points, and it rendered very nicely, and the map is very responsive. So this is a problem if you want to create this map, for example, in QGIS or any other software. So an example of how you can use Python and different libraries that exist to make a map of your big data efficiently. Okay, let's quickly take a look at our exercise for the week 3. So in this week, we are creating 3 maps. So as usual, we have a weekly reflection and a think beyond maps. So this is just the textual part of your exercise, and they have less weight this time. You only get 1 point from your weekly reflection and think beyond maps, which is about exploring ideas of how geographical data can be visualized non-cartographically. So just a short text, you don't have to go too far with this. The main weight of your exercise this week comes from a mapping challenge, and you have been given 3 options, 2 of which you have to choose. So you produce 2 maps, but you have 3 options. If you want to go with something else, you can also, if it is it's good enough, if it qualifies as, if it is comparable to one of options here, you can also use your own option. But yeah, one option is to use create a hex bin, similar to what we did in the class, in the tutorial. And there are a few ideas what data you can use. You have already provided the one CSV, for example. You can use another data from Ookla, speed test, which comes in Parquet. You will see that Parquet is a bit hard to work with in QGIS. CSV might be easier. That's why I have written a couple of lines here how you can use Python to convert Parquet data into CSV if you're using Python in any way. If you are not using Python at all, or if you're not comfortable with it, I have also provided a link to the data in CSV format that you can just download and use. If you're using QGIS, there are a few tips. There are some plugins that you can use for creating this kind of map. The second option is using mapping some origin destination data. There are a few examples provided here, but you can also come up with other data sets that qualify as big data, and you can use some of the skills that you have learned during this week. And the third option is a cartogram. If you want to create a cartogram like you see in the, you will learn about this in the QGIS tutorial, and that's another option. So 2 of these you have to make for the exercise, and you will submit your exercise as usual as a PDF file straight into the Moodle, and the deadline for it is It's actually, I guess, not Wednesday, but Thursday 29th. So it's actually Thursday. Yeah, so Thursday, end of day. And that's it for today.